God does not play dice with the universe, Albert Einstein. Einstein, stop telling God what to do, Niels Bohr. These two legendary quotes capture the heart of one of the greatest debates in the history of science. To Einstein, the idea that the universe operated on probabilities rather than strict laws was unacceptable. Bohr, on the other hand, championed the strange and unpredictable nature of quantum mechanics. This was more than just a battle of words, it was a fight over the fundamental nature of reality itself. Does reality exist independently, or is it shaped by observation? Welcome to the greatest scientific showdown of all time, Einstein versus Bohr. To understand this debate, we need to understand its fighters. Albert Einstein, already a legend for his theories of relativity, believed that the universe followed strict, predictable laws. His work showed that space and time were linked in a cosmic dance, bending under gravity's influence. But at his core, Einstein was a realist. He believed that reality existed independently of observation. Then there was Niels Bohr, one of the founding fathers of quantum mechanics. Bohr's work revealed a world where particles didn't exist in definite states but instead in a fuzzy cloud of probabilities, until they were measured. And this is where the battle began. In the early 20th century, quantum mechanics was emerging as a radical new way to understand the universe. It started with Max Planck's discovery of energy quanta and Einstein's own work on the photoelectric effect, which showed that light behaved like both a wave and a particle. But things got really weird when Werner Heisenberg introduced the uncertainty principle, the idea that you could never precisely know both the position and momentum of a particle. The more you knew about one, the less you knew about the other. Bohr embraced this uncertainty, proposing that reality was not determined until it was observed. But Einstein? He hated it. The intellectual war between Einstein and Bohr reached its peak in 1927 at the Fifth Solvay Conference, where the world's top physicists gathered to debate quantum mechanics. Einstein wasn't convinced by Bohr's radical ideas. He believed quantum mechanics was incomplete. To him, the idea that particles only took on definite properties when measured was absurd. Reality, he argued, should not depend on an observer. Bohr, on the other hand, defended quantum mechanics fiercely, countering Einstein's arguments at every turn. The debate was fierce, but Bohr seemed to have the upper hand, at least for now. Einstein, frustrated with the uncertainties of quantum mechanics, famously declared, "God does not play dice with the universe." Niels Bohr quickly fired back, "Einstein, stop telling God what to do." Einstein wasn't ready to give up. Over the years, he came up with a series of thought experiments designed to prove that quantum mechanics was flawed. The EPR Paradox, Einstein-Podolsky-Rosen Paradox. In 1935, Einstein and his colleagues proposed a thought experiment showing that if quantum mechanics were correct, then two particles could become instantaneously connected, no matter how far apart they were. This was called quantum entanglement, and to Einstein, it was impossible. He mockingly called it spooky action at a distance. By the way, we previously made a full video on quantum entanglement, where we dive deep into its mind-bending implications. If you want to understand more, be sure to check it out. Bohr, however, responded with unwavering confidence. Regarding the EPR paradox, he argued that quantum mechanics did not violate any principles of reality but rather redefined what reality meant. He insisted that entanglement did not imply faster-than-light communication but rather a deeper, non-local connection between particles. He pointed out that Einstein was still thinking in classical terms, trying to impose a definite reality onto a system where only probabilities existed. To Bohr, the paradox was not a flaw in quantum mechanics but rather proof that reality itself was fundamentally different at the quantum level. Each time Einstein challenged him, Bohr found a way to respond, reinforcing his view that quantum mechanics was a complete and self-consistent theory. For decades, Einstein's EPR paradox remained an open question. That is, until the 1960s, when physicist John Bell devised an experiment to test it. Bell's work led to the Bell test experiments, which were finally performed in the 1980s. The results? Quantum entanglement was real. Particles really could influence each other instantaneously, no matter how far apart they were. Einstein had been wrong. Quantum mechanics wasn't just a strange theory, it was how the universe actually worked. Then, in 2022, the Nobel Prize in Physics was awarded to Alan Aspect, John Clauser, and Anton Zeilinger for their groundbreaking experiments proving the reality of quantum entanglement, further supporting Bohr's view. These experiments confirmed that quantum mechanics is not just a theoretical concept but a fundamental truth of our universe. Even though Bohr seemed to have won the debate, Einstein's skepticism was valuable. His refusal to accept quantum mechanics at face value led to new breakthroughs in physics. Today, quantum mechanics powers quantum computing, the technology that could revolutionize AI and cryptography. Quantum cryptography, the future of secure communication. Teleportation and quantum networks, experiments are already showing real-world quantum teleportation. The search for quantum gravity, uniting Einstein's relativity with quantum mechanics, is still one of the biggest unsolved problems in physics. So, was Einstein completely wrong? Not necessarily. Some modern physicists believe there's still a deeper reality beneath quantum mechanics, something yet to be discovered. The Einstein versus Bohr debate wasn't just about physics, it was about the nature of reality itself. Does reality exist independently of us, as Einstein believed? Or is it shaped by observation, as Bohr argued? Even today, the true nature of reality remains a mystery. So now, we turn the question to you: who do you think was right? Einstein or Bohr? Does reality exist without observation? Drop your thoughts in the comments below, hit like if you love physics, and don't forget to subscribe for more mind-blowing science videos.